server people write the server application, and then there's some magic AJAX stuff that takes the methods that are exposed publicly on the server app and generates JavaScript over here that has a bunch of levers on it. And the levers on that JavaScript are named the same as the levers over here on the server, right? And then the client-side rendering people, all the UI designers, the people with pink hairs and lots of piercing, they don't know how to write Java, but they know how to write JavaScript. They are able to interact with this JavaScript object and pull the levers over here, and then magic state changes on the server, right? That is a client-server proxy. That's how a lot of AJAX works, because it really meets up with how a lot of companies have their development groups, right? The problem of that is that this JavaScript chunk over here that has all these levers has to have those levers up front, right? The moment you start using AJAX functionality, because it's asynchronous, you can't guess what calls happen in what order, right? Because page reloads aren't happening all the time. So you can't guess that somebody gets to step 2 of a step 1, because perhaps all that stuff actually just happens in the rendering. All of the methods that are ever going to be called by the AJAX are often downloaded with the first initial 250K of JavaScript that comes down with the site. And so you end up with a big chunk of AJAX with a listing of all of the methods and all of the parameters it takes and all the stuff it can do. We once did a pen test where they had taken a normal web application and they'd AJAXified it, doing some automatic magic hocus pocus. And our first day, we down and we look in the big chunk of AJAX that comes down, and we're looking at the methods, and it's like log in and transfer money and do this, change password, make me admin. That's an interestingly named method. Make me admin. And it turns out if you call it, your user becomes an administrator on the application. Why'd that exist? Why did make me admin exist in the Web 1.0 app as a parameter that you could put after logging in? I mean, who put that in there? A developer, right? Because they needed a backdoor, because developers aren't allowed accounts on production systems, but they're held accountable for the bugs. And every once in a while, they need to log in as an admin, and so they created a parameter that if you put make me admin equals 1, and any get request, all of a sudden you became an administrator. Now, if this was a Web 1.0 app and we had pen tested it, we never would have found it, right? Because you have to brute force every stupid phrase in English put together, right? Make me admin, make me root, give me right? You can't try all that stuff. But in the Web 2.0 world, all that stuff is automatically given to you. And you don't have to do all this stuff. You don't have to walk through. You don't have to spend all day doing enumeration. It just comes down in a nicely formatted list. And Zane's going to show you some examples of what those lists look like. Cross-site scripting. Now, like I said before, the good old days, the only thing dynamic on a website was the HTML, right? Images are obviously generally not dynamic. And JavaScript was only supposed to be for menus and stuff. When JavaScript was invented, the idea was it was a static bit of programming that you download and the program is the same, although the data input might be different, right? Well, it turns out that's not true. That causes a lot of flaws. But this data now can come in a lot of different ways. So we're going to talk about one possible way that you can do AJAX that has 4 different cross-site scripting injection possibilities. This is the same way Google Maps works, which is upstream we get HTTP gets, and then down. So this is the first initial login. Maybe I go to, this is webmail.com, which is AJAXified, and I say, give me index.html, and so I get index.html and a bunch of JavaScript, and then the JavaScript does asynchronous requests using XML HTTP request. It doesn't really matter what this format is. And downstream comes evaluable JavaScript. JavaScript that then gets wrapped in the eval statement here, right? So first off, the obvious injection attack against that is that JavaScript is already coming down and being executed. So why don't I just change what that JavaScript does as an attacker? I don't need to create a script tag. I don't need to create a style tag. I don't need the less than or greater than signs. In this case, all I have to do is break out of a JavaScript array. And I need the double quote, which double quote is not something that is sometimes filtered and not sometimes filtered by input filtering. And so in this case, this is code that comes down, gets executed by the client side, and was supposed to do some stuff. I control what's read. So I say, sure, I'll give you something to put into the array, and then I'm going to close the JavaScript statement. I'm going to do bad stuff. Obviously, this is where you actually put your attack code. And then I'm going to put this in here. Why do you think I put this right here as an attacker? Right, because I want the syntax to be correct. They put those double quotes and that semicolon there for me. If I break the syntax, what happens to the JavaScript? It just breaks, right? JavaScript does not have a very robust error model. If this thing was bad, this whole line would not get executed. And so we have to make sure that we make the things that exist to still make sense. As you can see, things like the less than and greater than sign script on mouse over, all that kind of stuff does not exist here, right? So this is injection attack number 1. So maybe they're looking for this injection attack. Maybe they're looking for double quotes, right? So what if I just put like some standard old double script in there, JavaScript, that doesn't have any double quotes in it? Well, anything that comes down that gets written into the HTML, that gets displayed to the user, has to be written into the DHTML, right? There's JavaScript, it takes something from the server, it parses it maybe a little bit, and then it puts it into the page. There's different ways of doing that. And there are, out of the 3 major methods, the methods being document.write, inner HTML and inner text, 2 of them will, if you write script into the stuff that gets written into the page, will execute the script right after that's done. So if you get something from the server, it runs, and then there's some JavaScript that takes the inbound JSON array and does a document.write to it, then the script tag is going to execute. And if it does an inner.html, the script tag is going to execute. If it does an inner.text, it's not going to. Are you sure 15 minutes? Because other guys went over, and we'd like to actually finish the prezo. Okay. How about we have a vote in 20 minutes if people want us to stop or not? We'll let the people decide. Isn't that what Toorcon's about? The people? So this is cross-site scripting number 2. The third way that the scripting might happen is the cross-site scripting might already be in the DOM. JavaScript and AJAX applications often go to variables defined in the browser and then use them automatically to do some stuff. One of the things they do is they dynamically write links, because using AJAX is a great way that you don't have to rewrite your app to work on qa.webmail.com and production.webmail.com and dev.webmail.com. If your JavaScript just goes through, asks the browser, what URL did I come from, and then rewrites all of the links automatically using that URL.
Is that a MIT's research? Can you do some stuff with?
Yeah, and this is a link to a MIT's web page that has a lot of good lists of variables that can automatically, can be controlled by an attacker. Most of these variables come from the fact that people can send you a link and you click on it, and they can set things like document.url, document.location, document.refer. So in an AJAX, this exists in regular apps too, but in AJAX apps, I think it's more common because people like to do little tricks that rewrite their stuff. So that's the third way of doing it. The fourth way of doing it is the fact that cross-site scripting, that AJAX relies on the fact that there are requests that happen invisibly to the user, right? There are requests that happen on the back end that are never seen by the user and never show up in the URL box in Internet Explorer, right? Those requests are made by XML HTTP request, and the response is handled by XML HTTP request. That response is not handled by the browser. What if the response is handled by the browser? That changes the security model. It changes what the input have to do. Let's say we have a webmail.com still. Webmail.com uses this GET request on the back end. After you go and you click on the inbox, it wants to get the list of all the new messages in your inbox. So it makes a request, get all the new messages, and the response is an array, and the array is filled up with lots of data with all the information from the all the mail that you have, right? So obviously this information is controllable by an attacker because they send you email. So an attacker sends a victim an email with a script tag. Maybe it's in the subject line of an email. And maybe webmail.com knows that's a bad thing, so they take any double quotes out of this, right? They don't allow double quotes into this, so you can't break out of the message array. And when they write it in, they use or they use inner text, so it doesn't execute, right? So they've thought about this already. Maybe the webmail.com person's leaving, like this gentleman, and doesn't know how this attack works, right? He's only going to know how 3 of them work. Oh, you're vulnerable now. And so an attacker sends the victim an email link. They look at it, and they read the email, and it says in the subject line, script do something bad, right? And they're like, wow, that's a really weird email. And then they go to their next email, which happens to have been sent by the attacker as well, and they click on this link. This is a link that the user never knew existed. It only runs in the back end of Internet Explorer, right? And so the victim clicks on that link, and now they get this as a response. Now this, when wrapped in an eval statement, doesn't do anything, right? What happens though if Internet Explorer gets this down as a document or as a text/HTML MIME type? Anybody want to guess what happens? Sorry? It runs, right? So it looks and says, I don't see an HTML tag, I don't see a body tag, I'm a little confused. I'm not sure what this is, although the MIME type says it's HTML. So I'll go through and I'll treat this as text. And so the user is going to see this stuff as black text in the normal like fixed space font in Internet Explorer. And then it gets to this and it says, oh, a tag, excellent. I am looking at HTML, and it will parse this as a script tag and it will run this script. So this is not run in the context of the actual application itself. It ran because of a link that talked to something on the back end of the application that the user never knew about. But I am guaranteed as the bad guy that this cookie exists because they clicked the link from the email, right? So that makes sense to people? So this is the fourth way. So this is kind of illustration. Cross-site scripting is a little harder in Ajax, right? Because you can't just think of stuff being written in HTML. You have to think about it being written in JavaScript. You have to think about it being written into the DHTML later, and then you have to think about what if it gets looked at directly by a browser because somebody clicks on the link. Oh, and you have to think about what's in the DOM, too. Oops. Okay, so there was a cross-site scripting bug in MySpace. Like I said, that's their entire business model, so there will be more cross-site scripting worms. This is the worm written by Sammy. He was a very, very lonely boy, and he wanted lots of new friends, and the way he thought he'd get these friends is by running script in their browser, which I guess if you are very emotionally stunted, I better not actually insult him because he's going to do something bad to our website. Sammy's a great guy. He's obviously very smart for a 13-year-old. He actually was smarter than the MySpace developers because he actually uses XML HTTP request. He wrote an Ajax worm on a non-Ajax website, which I think is kind of cool. And what this worm did is once you looked at Sammy's page and it had the script on it, it would go modify your page to include his script on it. So anybody that looked at your script page got infected. And then it would add you as his friend. And to add as a friend, he had to get this thing called a hash code and parse it out of the hidden parameters and then put it back into one of the posts. Why is that necessary? Why do they have that hash code in MySpace?
Are you sure you want to update your profile?
Right, so this is to stop an attack called cross-site request forgery or cross-site reference forgery. This is really kind of the new hotness. Although it's been around for a while. This is an excellent paper written by my partner, my business partner, Jesse Burns. Raise your hand, Jesse. That's Jesse. You can ask him all about XSRF afterwards. Although he mistakenly calls it cross-site reference forgery in this paper. He did not get the memo about what our naming convention was going to be. People call it both. Oh yeah, it's usually abbreviated XSRF or CSRF. That's a typo. Anyway, this is a very interesting vuln. It's almost universal problem with the websites we look at. What does it let you do? So I'll tell you a true story. One day there was a yuppie, and this yuppie was monitoring his net worth, right? Because the greatest yuppie porn is the stock ticker from Scottrade or Schwab or any of those sites, right? And he had his little stock ticker running in the bottom right corner of his desktop. And so that is a Java application that runs in an Internet Explorer window, and it sits there all day and it says, this is how much money you have, right? And just sits there all day, and that's all it does while he was at work, and he could very happily look at that and see how much money he has, which made him happy, right? While he was doing that, he wanted to make more money, so he wanted to find some inside information to trade on. So he goes to Yahoo Finance, the center of SEC investigations these days, and he goes and reads the message board, and he sees a message saying that I've got some leaked information, and there's a tiny URL, which I'm amazed at, and he clicks on an URL from tinyurl. He clicks on it, and he goes to cybervillains.com/news. He says, wow, this is an interesting name for a news site. But perhaps he's not that concerned because he's actually looking for illegal inside information, so perhaps some cybervillains would know something about it. And he goes and he reads this site, and it doesn't look that interesting to him because it comes from the Washington Post, and everybody here knows the Washington Post is not the paper of record. Where's Brian Krebs? And he reads this story, and he says he gets bored and he closes his window and he leaves. He does not click, nothing pops up. He does not accept any ActiveX control. He does not download anything.